So in this video, I'm going to answer the question, give a high-level overview of how a multi-layer perceptron learns. This is pretty much the simplest neural network, and the fundamental ideas in the training process are fairly similar for more complex networks. So a multi-layer perceptron is a fully connected, feed-forward neural network with at least one hidden layer. Fully connected means that the neural network only consists of fully connected layers. A fully connected layer is a layer in which each neuron receives input from all neurons in the previous layer, and a feed-forward neural network is a neural network in which connections do not form cycles. Therefore, all information can be considered to flow forwards in the network. This is in contrast to recurrent neural networks, in which certain connections form cycles. As a side note, the name multi-layer perceptron is actually a bit of a misnomer, as the original perceptron model only uses a step function as an activation function, whereas multi-layer perceptrons often use other activation functions. So at a high level, the learning/training of a multi-layer perceptron starts with the initialization of its weights and biases. A random initialization of weights helps break the symmetry of a neural network, which enables neurons in the same layer to learn different patterns in the data. In the forward pass, the input data is passed through the network to obtain predictions. This is sometimes also referred to as forward propagation. The loss function is then used to compare the predictions to the actual values to calculate the loss. An optimizer, using the backpropagation algorithm, updates the weights and biases according to the loss value. Backpropagation is the algorithm to efficiently calculate the gradient of the loss function for a single weight/bias using the chain rule. The gradients of the loss function are used by the optimizer to update the weights and biases of the network. The backward pass refers to the series of calculations to update the neural network's parameters described in steps 3 and 4. It should be noted that backpropagation is commonly used to refer to the entire backward pass. The forward and backward pass form a single parameter update step or iteration that is repeated, which forms a training loop. An epoch is one complete pass through or usage of all the training data. And so that's all for this video. Thanks for watching.